Hello everyone, welcome to the Django tutorial series. In this tutorial step, we're going to write REST APIs with the Django REST framework. It's not like we can't develop APIs with Django, but a lot of the heavy lifting is already taken care of by DRF, Django REST framework, like access control, serialization, deserialization, JWT authentication, pagination, rate limiting, etc. We will explore how DRF makes our life easier. For our tutorial, we'll be using the 3.12.2 version. Make sure to add REST under framework in the installed apps in your Django settings.py file. I'm going to create a package in the project root and name it as API. I normally break down my APIs into different versions, and each version contains its own business logic, routing, etc. With this, I can also maintain backward compatibility. As you can see on my screen, I'm going to modularize my folder structure. You are free to use your own approach and play around with it. There are 4 files under Organization. Serializer.py. According to DRF, serializers allow complex data such as query sets and model instances to be converted to native Python data types that can then be easily rendered into JSON, XML, or other content types. URLs.py. It's where you define the mapping between URLs and views. You can also consider them as routes. Validator.py. We will use this file to write our common validation code, which can later be reused. Views.py. This is the file where we are going to write all of our business logic. Let us first start implementing our business logic in the views file. We'll be writing our first API that will perform 2 operations: creating a new organization and listing all the organizations. I'll be importing list create API view from rest under framework.generics. According to the Django documentation, generic views were developed as a shortcut for common usage patterns. They take certain common idioms and patterns found in view development and abstract them so that you can quickly write common views of data without having to repeat yourself. There are several generic views provided by DRF. List create API view is much better than using the basic API view. If you try writing the same logic in API view, then you need to implement get and post methods. But in the case of the list create API view, the get and post method is already implemented. So this is how Django makes your life easy by writing less code. Now I'm going to inherit the generic view in our class. Query set and serializer under class are the mandatory attributes you need to pass. A query set represents a collection of objects from your database. For our case, we are trying to get all the objects from the organization model. According to the Django REST framework, serializers allow complex data such as query sets and model instances to be converted to native Python data types that can then be easily rendered into JSON, XML, or other types. Serializers also provide deserialization, allowing parsed data to be converted back into complex types after first validating the incoming data. For example, when you pass a JavaScript object through an API, it gets converted to a native Python dictionary. As you can see, we are using Model Serializer. It provides a useful shortcut for creating serializers, which deal with model instances and query sets. We will be using dunderAll in our fields attribute to display all fields present in our model. It is strongly recommended that you explicitly set all fields that should be serialized using the fields attribute. This will make it less likely to result in unintentionally exposing data when your models change. In permission under classes, I will be providing allow any. Basically, anyone can access my API without any authentication. It's not recommended to do it in production. In my upcoming video, I will be explaining how to protect our APIs. Our API implementation is complete. You can see it's only 3 lines covering query set, serializer under class, and permission under classes. Just compare it with your vanilla API view. You need to write so much logic to handle all the scenarios and edge cases. Let's register our API in the urls.py file. When using class-based views, you need to pass as under view along with your view name. This provides a function-like entry to class-based views. To know more about class-based views, please visit the link shown on the screen. Our URL route is now registered. Let's begin by opening Postman. Postman is a popular API client that makes it easy for developers to create, share, test, and document APIs. This is done by letting create and save simple and complex HTTP or HTTPS requests, as well as read their responses. I'm now going to provide the organization route. We'll be performing a POST request to store organization information in our database. Oops, looks like I missed the /. Okay, it's working now. As you can see on my screen, the API is returning a 400 bad request because we didn't provide the necessary information, and we're receiving a validation error saying the field is required. This is one of the great parts of using a serializer, as they do the heavy work for you. The three fields, name, registration under code, and established, are not null in our database table, so we require a mandatory value to be inserted. If any column has null set to true, then it won't appear over here because it has now become optional, and all this is taken care of by Model Serializer. Now I'm going to provide all the necessary information, and after that I will click on Send. Awesome, the data has been successfully stored in our database, and as you can see, we received a JSON response in return, and the new row has been created with an ID of 1. Let's verify that record in our database. Yes, the record is successfully reflecting. Let me try to send the same request again and check what happens. Okay, you can see that we are receiving an error. Organization with registration code already exists. What I know is I haven't written this validation message. It's taken care of again by the serializer because registration under code is a unique field in our database. This is amazing how serializers are performing validations based on our data model. We even have the flexibility to write custom validators. I'm going to remove the record from my database and reinsert it again. But before that, I want to customize my response. Instead of showing all the inserted objects, I also want to add a message flag. I'm going to click on List Create API View. As you can see on my screen, it inherits List Model Mixin, Create Model Mixin, and Generic API View. I will click on Create Model Mixin. Under the hood, it is actually creating a model instance. I will override the create function by changing the response structure. Let me first copy the function and paste it in the organization API. I will do the necessary imports which are required. Next, I will do a minor modification in our response by adding 3 keys: status, message, and data. Let's now test again in Postman. Okay, now we got a customized response from our API. This is how you can play with the APIs by overriding the base implementation. I will add one more sample record just to validate that the API is working. As we are done with the post method, let's move ahead with the get operation, as we are using list create API view, which supports both post and get operations. You can see on my screen that we are viewing both the records which got inserted in our database recently. Just imagine if you had used the vanilla API view, then you would add so much work needed just to accomplish this. We're done with get and post. Let's move on and focus on implementing put and delete. I'll be creating a new class which will inherit the generic view retrieve, update, destroy API view. It is used for read, write, delete endpoints to represent a single model instance. It supports get, put, patch, and delete method handlers. As you can see in get under query set, we are passing PK, which is actually the primary key, which is the ID column which we are referring to. Next, I will register the API and the URLs. Let's now test our endpoint in Postman. As you can see, I'm performing the same get operation, but with a small difference. I'm actually passing an integer, which is actually referring to the primary key or the ID in our table. We got the information for the specific row in our table. List API returns us all the objects, which Retrieve API will give information for a specific object. Now I'm going to perform a put operation to update my record. I will provide the information in the body, but I will also provide a different value for the registration code. I'm also going to change the response structure for the put operation. Okay, our record has been successfully updated, and you can see the customized response. Let me verify that in our database. Let's complete the final operation by removing the record from our database by performing the delete operation. I'm going to remove the record for ID number 3. Okay, we've successfully removed the record. We have received a 204 no content HTTP response. This is a default behavior in the delete method that we don't receive any JSON response in the body. Let me verify that in the database. Yes, the record has been successfully removed. This completes the cycle of performing create, read, update, and delete operations in our APIs. There are many ways you can create APIs, like using a function-based approach, creating from scratch by using vanilla API view, or using view sets. View sets are really amazing to try out. Please check the official DRF documentation. In the upcoming video, I'm going to show you how to protect our APIs using JWT authorization.